Section 3.1, problem 54. So in this question, you are given a curve, which is y is equal to x square root x. And then you are asked to find the equation of a tangent line to this curve that is parallel to y is equal to 1 plus 3x. So those are your two key functions. Now, what does it mean for two lines to be parallel? Well, that means they have the same slope. Now, in this question, our goal is to find a tangent line that is parallel to this line. So the first thing we need to ask ourselves is, what is the slope of this line? And of course, we know that the slope of a line is the coefficient of the x variable. So in that case, our slope is 3. So to reword the question, given our new information, we are essentially trying to find a tangent line to this curve whose slope is 3. So to do that, first we need to provide the derivative of y, because the derivative function of y gives us what the slope values will look like in relation to x. So the first thing we do is dy excuse me, it is dy dx and we're going to rewrite y in a more manageable form. Instead of writing it as x times square root of x, we note that this is equal to x times x to the 1/2, which again can be rewritten as d dx of x to the 3/2. And now we can apply the power rule to get the derivative is 3/2 x to the 3/2 minus 1, which is 3/2 x to the 1/2, or 3/2 square root of x. So we need to find when is 3/2 square root x equal to, and again remember the value that we need is 3, so when is it equal to 3? So let's solve this equation. Three halves square root x is equal to 3 implies, and if we multiply both sides by 2/3, we get 2/3 3/2 square root x is equal to 2/3 times 3. Now, why did we multiply by 2/3? Well, now the 2/3 and the 3/2 in front of the x, in front of the square root x, cancel out. So we get square root x is equal to, and then if you look at the right-hand side, the 3 and the 3 cancel out, and we get 2. So if the square root of x is equal to 2, then of course that means x is equal to 4. So that means at the point 4 times square root 4, right? The reason we write 4 times square root 4 is because our function is x times square root x, and we're evaluating it at 4. We can rewrite this as 4 comma, the square root 4 is 2, so that's going to be 8. So we now know that at the point 4, 8, the tangent line to y is equal to x square root x has as its tangent line something that is parallel to 1 plus 3x. So now let's get the precise tangent line equation. So recall the point slope form, which is if you have a slope m, at some point xy, let's give this some specific names. Let's call this x naught, y naught. Then the equation of the line through the point x naught, y naught with slope m is y minus y naught is equal to m times x minus x naught. Now all we got to do is apply this to our situation. So in our situation, the point x naught, y naught is 4 comma 8. So plugging that in, and furthermore, we should note that our slope m is what? Well, it's 3. So plugging all of those values in, we get that the equation is y minus 8 is equal to 3 times x minus 4. And then doing some simplification, that means y is equal to 3 times x minus 4 plus 8. And then distributing the 3, we get this is equal to 3x minus 12 plus 8. And then finally, combining the negative 12 and 8, we get 3x minus 4. And so there you go. The answer to this problem is the following then. The tangent line to the curve y is equal to x square root x that is parallel to y is equal to 1 plus 3x is the function, is the line y is equal to 3x minus 4. And this tangent line is tangent to our curve at the point 4 comma 8.